Hello, this is Dr. Amunapriya, Associate Professor, Tripoli, Rojini College of Engineering and Technology, Palkulam. We are discussing about the theory sub-course for system analysis of lecture Introduction and per unit representation. Regarding the power system network, it consists of a generating station together with the step-down transformers, step-up transformers, transmission lines, feeders, and then the distribution side we do have the distribution substation, service mains, etc., which are being connected to the consumers. This is a single line diagram where it is a diagrammatic representation of a power system in which the components are represented by these symbols. These are the general components of a power system. Normally, while considering the equivalent circuit, we used to draw the generator and motor as such with the resistance, inductance, and then the voltage value. And next, this is regarding the transformer where it consists of the resistance, inductance, impedance, reactance value. Together we do have an impedance, and the shunt parameters are representing the winding current and the magnetizing current. And regarding the transmission line, it can be represented either by pi type or T type. And next, this is the motor, induction motor, where we do have the resistance, reactance, and the R0 and X0 value, and the load resistance considering the slip value S. Now, for power system analysis, the basic thing what we have to do is we have to represent the values in per units. So what is the per unit? Per unit value is nothing but the ratio of actual value to the base value. So what is the need for using a per unit value? Normally, let us consider a transformer which do have two sides, that is a primary and the secondary side. If it is a step down transformer, at the primary side we used to have a larger voltage, and then the secondary side we used to have a low voltage. So obviously we cannot have a comparison. We used to have a transformation ratio, but we can't compare both the values. And sometimes it may be some values may be in voltages, some values may be it may be in kV, sometimes it may be at MVs. So the comparison is a difficult one, and what manufacturers usually do is they used to represent the parameters, component parameters in per unit values. So per unit value, it is like a ratio, right? So the value varies from 0 to 1 only. So for all the values, it doesn't have any unit. So if it is a voltage means, then obviously we will be calculating kV by kV. So if it is MVA, we used to calculate it as MVA by MVA. So obviously we are getting a per unit value there. So what we will do is initially, this is the value for Z per unit. Z per unit is equal to Z divided by ZB, that is actual impedance by base impedance. For calculating the base impedance, let us go for this equation. So what is Z by Ohm's law? Z is equal to V by I. What is I? P is equal to VI. So I is equal to P by V. So here MVA divided by KVB is the current and voltage is KVB. So while substituting, we used to get this equation. ZB is equal to KVB the whole square divided by MVAB. Let us substitute it here and we get the Z per unit value. In the analysis part, what we used to do is we used to consider the old base values and we used to find out the new base values. So for that purpose, we used to go for this equation. The last equation is the per unit new value corresponding to the per unit old value. So how we are going to obtain this last equation is, let us consider the first equation. Initially we have seen that Z per unit is equal to Z into MVAB by KVB the whole square. So Z per unit old is as it is. This is the first equation. From the first equation you can find out the value for Z. Let it be 2. For the third equation, instead of old in the first equation, we are going to have new in the third equation. Here, the second equation can be substituted in the third equation. The Z value has to be substituted. Obviously, we will get Z per unit mu is equal to Z per unit old into kVb old whole square by kVb new the whole square into MVAB new by MVAB old. These are the advantages of the per unit calculations. Whether it is a primary side or secondary side, we can easily compare with the help of per unit, as there is no voltage. Even if it is a three-phase transformer, we need not consider about whether the connection, whether it is a star-star connection or delta-star connection, etc. And the per unit value, as I said, it will be less than unity. Now let us draw the impedance diagram from the per unit the representations. How we can draw the impedance diagram? All the components have to be represented by the single phase equivalent circuit. The impedance between the neutral and the ground can be omitted, and the shunt branches of the transformer equivalent circuit can be neglected. And what about the reactance diagram? It contains only the reactances. All the resistances and capacitances have to be removed. This is an example of a reactance diagram. Next, let us see how we have to calculate. Initially, let us draw the single line diagram of any given circuit. From the single line diagram, let us consider a kVb value, base kV value and base MVA value. Suppose if it is given in the problem, means it is not it's not a problem. Then if it is suppose not given in the problem statement, then what we have to do is we have to consider one as a reference. Initially we will consider the generator as a reference, from where we can start the calculation. While we are crossing the transformer, we have to consider the transformation ratio for getting a per unit value corresponding to the primary side. Then we can go for this equations. Directly we will be getting all the per unit values, and finally we can draw the diagram. These are nothing but the leakage impedances. Thank you.